Yeah, my screen is presenting to all. My
Yes,
screen
sir.
is presenting to all. Empty Word document is there. Okay. Yeah. So we have one more topic in normalization. Uh, in normalization, we have seen different types of normal forms. So 1NF and 2NF and 3NF and BCNF. And one more topic is there, lossless and lossy decomposition is there, and dependency preserving is there. All these are different types of techniques to remove the redundancy from the given redundant table, right? So we have one topic very important. We have seen one more topic is functional dependency. In functional dependency, so we have two attributes, x and y. The equation is x tends to y, so the y is depend on x. Here the x is a determinant, x determines y, right? This is functional dependency. Now the today topic is that we have a multi-valued dependency. We can represent MVD, right? Multi-valued dependency. In exam, final exam, there may be chance to get clear a multi-valued dependency, or there may be chance to get they'll ask what do you explain MVD. Don't confuse MVD and multi-valued dependency, both are same, right? Multi-valued dependency, right? So which is called as multi-value dependency, right? So now what is multi-value dependency? This is functional dependency extends to a representation. So basically the multi-value dependency is represented by using double arrow, right? So how to represent that one? This one, this is uh, we have is associated with multiple values of p. This is multiple values of p, right? So remember the A is multi-value dependency is B. Here A is a same values. The A attribute consisting all the values are same values. Here the B is a multiple values for the same values of A. So this is the meaning of multi-valued dependency. And if there are two columns A and B, and so if for a given A there can be multiple b, then we can say that multiple values are existing between a and b, right? This is the meaning of multi-valued dependency, right? Next we can see with one example. We have a example. We have two tuples t1 and t2, right? In the relation capital R, have the same a values, have the same a values, have the same a values means we can represent a tuple of t1 of a equal to t2 of a equal to t3 of a equal to t4 of a. If the table capital R consisting of four tuples t1 t2 t3 t4, the all the tuples of a attribute values are same. This is the meaning of T1 of A and T2 of A and T3 of A and T4 of A, right? So here where b the b values of t1 and t3 are same, you can represent by using, so here values are same. How to represent? If you consider b values, this is a values already determined. b values b values are same. t1 and t3 tuples are same, and t2 and t4 tuples are same. So how to represent this one? So t1 of b equal to 3 t3 of b, and the next one t2 of b equal to t4 of b. So this is the meaning of the tuple t1 and t3 values are same, and the tuple t2 and t4 values are same, right? So we can understand easily what is this a values or what is b values. Now we have to see what are the values existing inside the relation capital R, right? Consider a, b, c. We can represent one more tuple for our better understanding purpose. Tuples T1 and T2, T3. The A values are A, small e. All tuples values are A. Next B values are B1 and B2 and B1 and B2. And capital C, this is the one of the attribute of how to represent this one, C1, C2 and C2 and C1. So tuple T1, row 1, row 2, row 3, row 4. In DBMS terminology, the row is called as tuple, right? So here the column name is called as attributes, right? The table name is called as entity, right? So this is the one table. This is one table, right? This is one table. Just wait. Right? This is a table. One table. How many attributes? Three attributes are there, and one more extra column is there for our better representation tuples. Here from the table, so already we have determined for each value of capital A, already T1 of A equal to T2 of A equal to T3 of A equal to, this is the meaning of this one. All these are same values, right? And T1 of B and T3 of B, T1 of this is T1 of B, this value, and T3 of B, this value is same, and T2 of B and T4 of B. So this one, and this one is same. Here we have to understand the multi-valued dependency concept. From the table, for each value of A, each value of A, there will be set of B values associated, then the multi-value existing between A and B and A and C also. Here, if you see here, so A and C, the value of A, C is there, C1 is the value of B, C1 is there, value of A, C1 is there, and the same way, same values of A, C2 and the C2 existing. Here, the multi-value, these are the multi-values, B values for the same A. These are the multi-values for the same A, so that the multi-value dependency is existing between A and B, these two, and A and C, A and A and C. This is the multi-valued dependency table, right? So here there are three additional rules involving only multi-valued dependencies. So here, so what are the three rules existing in multi-valued dependencies, right? So here, rule one, rule one, rule one. So multi-valued dependency complementation. Multi-valued dependency complementation, right? So what is this rule? So if A is multi-valued depend on B, then A tends to A tends to A tends to what is that? A tends to capital. This is one rule. And rule two is that rule two is that rule two is that and just wait. Okay. And rule two, augmentation, multi-valued dependency, augmentation is there. One more rule is there. If A is multi-valued depend B and C superset are equal to D, then CA multi-value dependency of B, right? This is another rule. So next one, rule three, multi-valued dependency transitivity. Already we have seen in functional dependency properties, there are different types of decomposition is there, transitivity is there, and union is there, intersection is there. All these are, we have around 10, 9, 8 to 9 functional dependency properties are there. Like that, in multi-valued dependency, we have different types of different types of properties are there. Here, first one is complementation, augmentation, and transitive dependency. A transitive dependency is that if A tends to B, already you know that simple transitive dependency in functional dependency, A tends to B and B tends to C, then A tends to C, like that. B multi-valued dependency C, then we have to describe A is multi-valued dependency. A is multi-valued dependency. We have to write like this, C minus like that. We have to write in multi-valued dependency, we have to write like this. Or one more representation, A tends to A multi-valued dependency to C. This is also right. This is about a multi-valued dependency concept. And the next one is that, so we have seen how many normal forms are already in normal forms. What are the normal forms? We have discussed 1NF, 2NF, 3NF, and 4NF is there, not yet discussed. 5NF, and this lossless and lossy decomposition, and dependency preserving. We have different types of there, lossless and loss, right? Right. Okay. Next, we need to discuss about fourth normal form, right? Fourth normal form. A table is in fourth normal form if it is in Boyce-Codd normal form. The first rule is it should be in BCNF, Boyce-Codd Normal Form, and it does not have any independent multi-valued parts of primary key and or any multi-valued dependency is existing inside the table, we have to remove that multi-valued dependency. Right? Already you have seen what is multi-valued dependency. According to the BCNF, the left-hand side should be candidate key or shopper key, right? So, so all candidate keys should be on the right hand side of the functional left hand side of the functional dependency, right? So for example, we have to discuss with the example for this fourth normal form. Let us consider a table in which we have a student name, the subjects, she learned something, the language, and she knows all the stored in the table. So the student name and the subjects, what she learned, and one student can learn or more subjects, and simultaneously no or no zero subjects or more languages. We can see that there are two independent multivalued facts about some relationship. I'll discuss with the example, right? So we have table, the student table, student table, or we can call it as STD simply. We can represent STD. It has different types of attributes. So STD hyphen name is there, subject is there, language is there. All these are attributes of the student. Right? Now we have to discuss with the values of these three attributes. The first student name is that STD and hyphen name, subject, and the language. We have student name. Let us consider take Gita. The subject name is mythology, and the language is English language. And next, Gita. The subject name is psychology in English. And the same Gita, mythology, Hindi. Same name, same the student, same one more psychology, Hindi, Gita, some gardening, English. If you see here this table, this is the table consisting of multi-valued dependency. The student name is Gita. He knows Hindi and English. The subjects she learned mythology and psychology and gardening. So the mythology is she learned in English, and psychology she learned in English, and the gardening. Uh, two languages are in mythology. Two languages are um, uh, two subjects are in one English language, and two subjects are in another language, Hindi, and one more another subject is gardening. If you observe here, according to multi-value dependencies, the student name is same. There is a different values are existing for the same student in subject and language. Now, according to 4 and F, it should not have a multi-valued dependency. Now we have to decompose this original table into two more tables. Then we can remove the multi-valued dependency from the original table, right? So here also we can adjust, we can, it exists somewhat is that primary key and foreign key relationship. So wherever you go in a fifth normal form and a third normal form and anything, all these are decomposing the values from original table into some other different value and different tables. So if you are decomposing the values from original table into the different tables, after combining these three, it may be for suppose first table is there, R table is there. We are decomposing this table into R1 and R2 and R3. So these three tables should be in that particular a normal form, satisfies some particular normal form. But if you combine these three, we should get a original table. Otherwise, we should not get accurate and sufficient data. Right? We are not maintaining any consistent data, sufficient data, efficient data. Right? So if you split these three tables, it existing primary key and foreign key relationship, so that here these three are having some integrity constraint. Right? In the same way, here, if you see in this table, student table, we can see that Geta, this is the Geta is studying two subjects and knows two languages, because these two facts are independent of each other, so that the information about Geta has four rows, right? Right? Four rows, right? Next, if Geta starts studying three subjects, gardening, we would need to add two more rows onto the student table. One is in English and another one is Hindi, right? The process of bringing in this table into fourth normal form split the independent multi-valued components of the primary key into two tables, right? And the primary key for the student table is currently a composite key, right? Made up of three columns: student name, subject, and language. The above table contains two independent multi-valued dependencies, hence the table violates the condition, right? If you split these two tables into two independent multi-valued dependency, separate the tables, subject, student subject and student language is one table, and a student name, or what is that, student name and subject is one table, and student name and language is another table. Better to split that one, right? How to split? So what are the two tables? The first table is student underscore subject. This is if it is subject related, so that we have to maintain student underscore subject. So it should have student name, comma, subject. What are the values inside this student table? So student underscore name and subject related, this is one table. So Gita mythology and same Gita psychology, and so take a uh, more one more table, one more. So here, I'm sorry, this is not Gita. Some other name, some Suresh. Take some Suresh. So Suresh and gardening. So we have three tables. Next on three rows, and second, this is subject related. How many subjects are there? Subjects are there. One is mythology, and this is psychology and gardening is there. These three are. The Gita is studying two subjects, so that mythology and the psychology. The Suresh is studying the subject gardening in the English, so that this is related to only subject table, so that student name and subject. And second one is student underscore language, student name and language. And we have to define the table which we have describing for the relationship student language. This is one table. Student std underscore name and language there, same Geeta. She knows one English language, and Geeta, she knows another language. What is that? Hindi. And Suresh, English. Okay. So this is second table, right? So we can see that the decomposition reduce the redundancy here, reduce the redundancy with respect to both independent multi-valued attributes, relationships, subject and language. From the above table here, table, we need to add subject for Gita. For suppose if you want to add one more subject for Gita, we have to add one row for the student subject. For suppose if in the if you want to add a mythology subject table, we can add in mythology and psychology and biology. So Gita biology we can add one row instead of adding two rows English and Hindi in original table. We can add only one row in this first table, right? So right, this is the advantage compared to this original table. We can reduce the table into two more tables, so that so we are, of course we are not reducing full redundancy. Somewhat compared to previous table we are reducing very less redundancy, right? The advantage above this table is instead of updating two rows, so here updating two rows, we can update a single row. We can update a single row after decomposing the table. After decomposing the table, then we can take care of update anomalies from the decomposed table, right? So here, if you want to update this table, we can update directly in one row. Here, if you want to update original table, we can update in now to in English and Hindi also we can update, right? This is about fourth normal form, right? So and next we have seen this is about normal forms, different types of normal forms we have. And so one more topic is there for our lab session. Already we have seen what is the different types of DML statements are there, and DDL statements are there, and TCL statements are there, TCL, DCL statements are there, different types of what is that queries are there. Right? We have seen data manipulation language statements, and next one data definition language statements are there, and next we have to know what is TCL statements, what is DCL statements, right? Mm, for our better understanding purpose, we have different types of what is the table DCL, data control language, right? Data control language statements are there, right? So for DML, what is that? DDL is there, DML is there, and DCL is there, TCL is there. DML select and insert, delete, update is there. Next alter, drop, and one more remaining, all these are comes under this one. And the DCL data control language we have a grant, and revoke. Next one, TCL save point, commit, and roll back. All these are different types of one. Now what is a data control language? So here basically we have to give uh, privileges to the user. Privileges to the user. For suppose if you are existing, if you are existing uh, customer user in a particular company, I am the administrator for this company. I need to give all the privileges to the user. I need to take all the privileges from the user. Then how to give that granting the privileges to the user, how to revoke that privileges to from the user. The privileges either be granted to the user with the help of a grant statement. The privileges are, what are the different types of privileges? The privileges are uh, the privilege may be select, the privilege may be insert, it may be alter, it may be delete, right? So all these commands, whatever the administrator wants to give some privileges to the user, the administrator may grant the permissions to the user, so that the user can utilize all these privileges, right? By using grant command we have to give the permissions to the user, right? So here we have a grant command. How to this how to give the permissions to the user. Just wait. Right. So we have one syntax for this uh, granting permissions to the user. The permissions are how to give that grant. So we have to write grant, what we have to given for this privilege name underscore name on what object, means table name, object underscore name, and to whom, username, or it should be, are you giving private or public privilege, and what is that role name. All these are optional. We have a chance. If we give otherwise, no need to give all these things. Better to give the username with grant option, right? So here what how to describe that example name. I need to create one user, one user. So for that user I have to give privileges. I already how to create user. Username is username. How to give username, particular some Suresh user is there. Suresh identified identified by some name Sai, right? So here the username, the create user Suresh identified by Sai, right? So I am creating one user Suresh. So for that Suresh I need to give the values to the, so already if you type this one, if you execute this one, user created, output is user created. So once the user is created. If the user trying to select, for suppose this user having some what is that grant, what is privilege select, grant select on MP to user Suresh. If the size is given like this, grant select on Suresh to what is grant select on MP2, what is that username is Suresh. So now the Suresh is having some select privileges are there. So how to how to how to grant that one once already created. Now I need to give grant select, grant select on employee table. We have employee table employee to Suresh. Now the user and the administrator is giving select privileges to the Suresh. Now the Suresh can perform selection of whatever, what are the different types of selection operations on this table. So how to perform the table? Usually the Suresh will go to inside that SQL Plus and select star from. Now the Suresh needs to give system.emp, like that we have to give. Once you execute this one, so what are the values inside the employee table, it will display, right? So here it will display because of selection command, right? So for suppose once the Suresh is trying with the selector, if he is trying some update and insert and alter without knowing this administrator, the Suresh cannot perform all these operations because the administrator is given only selection operations to a particular Suresh user, right? So this is the granting some privileges to the user. How to revoke, how to take back from the privileges from the user. So we have a revoke command. So what is the revoke command? The revoke command is that, so we have to take privileges what we have given to the user. So revoke select, already we have given this select on MP from whom? So Suresh. So we have to take the, this select privileges from the user. So once you execute this one statement processed, this is the output. Once it is processed, if you are trying to see the values from the table, like select a star from system.emp by using this Suresh user, uh, you can get the output table or view does not exist, table or view does not exist. So this is about DCL statements on data control language statements, right? So we have similarly we have different types of tables transaction control language statements are there. So point and commit and rollback, all these are different types of TCL commands, right? So remember multi-valued dependency and fourth normal form, and actually this is not related to grant and revoke, these the DCL and TCL these they are not related to this normal form. We have pending one more topic is there, so that I discussed in this class. Okay, so this is today's class. Uh, right, this is the today's class. You know that what is fourth enough and what is multi-valued, grant and revoke DCL commands. Okay, so this is the class. I'll stop this class. The time is almost to 10 o'clock. So thank you. We'll continue day after tomorrow on more classes. I think day after tomorrow afternoon you have lab. Yes or no?
Yes, sir.
Yes,
Hello?
sir. Yes, sir.
Okay. Okay, we'll meet tomorrow afternoon. Um, okay, thank you. I'll stop the class. Thank you. I think screen, the entire class is visible to you.
Yes, sir. Visible, sir.
Yes, sir.
And similarly, my voice is clear to you.
Yes,
The
sir.
entire session. Okay, okay. Thank you. Thank you. Thank you.